Hey guys, this is where we left off from class today, so let's go ahead and jump into what we're talking about today. Now that we've been talking about degrees, we've been talking about radians, let's talk about what the unit circle is. So we're going to put that over here in the margin. So the unit circle, remember, we're going to draw it ourselves, looks like this. Remember, a unit circle means that the radius is 1, so we can draw that right there. That also means, just like we know, this is our x-axis, and this is our y value. At this point here, because we're going over, starting at 0, 0, we go over x, up y. That point is called x, comma, y, right? So whatever that x value is, whatever the y value is. Okay, so that also means that if this is our theta, make this a little smaller. If this is our unknown theta, that if I label this opposite, hypotenuse, and adjacent, that our sine of theta is the opposite, which is y, over hypotenuse, which is 1, which is just y, and that our cosine is our adjacent over hypotenuse, which is just x. So this means that x is just the cosine of theta, and that y is the sine of theta. This is super important to remember, so that if we have x comma y, we also have cosine theta comma sine theta. Remember that x and y are alphabetical in order, and so are c and s also alphabetical, okay? So as we're looking at these triangles, I can also see here that if we were talking about any other radius, go ahead and draw another circle right here. Okay, so let's say we're looking at another radius. Let's say if it wasn't 1, we'll just call it r for radius. That we know this point here on the circle, if I draw this down and make a triangle, I know this is x, this is y. Again, this is the point x comma y. That if we're talking about the sine of theta, it's still the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. And the tangent, again, is opposite over adjacent. Okay, so that is kind of a review, all right? So let's talk about, what if we were talking about reference triangles? Now remember, reference triangles mean that you're going to draw the angle to the nearest x-axis. This is super important because if I draw it to the y-axis, it's going to give me the wrong answer. So it's got to be to the nearest x-axis. So here's what that means. If this is my point, I'm going to make it a triangle to the nearest x-axis. Well, remember, the x-axis is here. So the quickest way for me to get from this point to the x-axis is a line straight down. So we're going to go ahead and draw a line straight down. That makes a right triangle for me. I know from here to here is my missing angle. That's theta. So from here in my triangle that I just drew, this is my opposite side. Here's my hypotenuse. Here's my adjacent. Now remember, if this is the point -3 comma 4, that means my x direction, I'm going -3 up 4 in my y direction. The negative is really important because it tells me that we're going to the left of the origin, or 0, 0. If that's true, how do we find the hypotenuse? Well, remember, we know a squared plus b squared equals c squared in a right triangle. This tells me that -3 squared plus 4 squared will give me c squared. Well, I know that's 9 plus 16, which is 25 equals c squared. If that's true, we take the square root and we get c equals 5. So that's going to be right here at the hypotenuse. So if we're looking for the sine of theta, which is the opposite over the hypotenuse, we know the opposite side is 4 and the hypotenuse is 5. Okay. So what about if I gave you some point P, and we call the point P -3 comma -6. So let's, whoa, what just happened? Let's sketch this the way we would any point, right? So we go -1, 2, 3, down 1, 2, 3, 4, 5, 6. So the point would be about right here. Okay, so again, we're going to draw that reference angle, which means we draw it to the nearest x-axis. So how do I draw this? I'm going to draw this angle from the center, the origin, and straight to the x-axis. So here's my right triangle. We're going to make everything into a right triangle. So from here, here's my unknown angle. And this tells me, I know that in my x direction, this is -3, -1, 2, 3. So I'm going to label that. This right here is -3. And then here, we went down 6. So we know that a side can't be -6, but it does tell me that it's below the x-axis. With that said, how do we find the hypotenuse? Remember that it's going to be a squared plus b squared equals c squared. So this becomes 36 plus 9 equals c squared. So c equals the root of 45. We're just going to leave it just like that. Don't worry about simplifying it for now. So if I'm looking for the cosine, remember cosine is the adjacent over the hypotenuse. So from the angle, I'm going to label opposite, hypotenuse, and adjacent. So we know the adjacent side is -3, and the hypotenuse is the root of 45. I'm going to let you guys leave it just like that, unrationalized. Okay, so what about this one? What if theta is in quadrant 4? So where is quadrant 4? Remember, it goes 1, 2, 3, whoopsie, 3, and 4, okay? So this angle is in this quadrant. I'm going to draw it right there. And I'm always going to draw it, remember, up as a reference angle to the nearest x-axis, never to the y-axis. So here's my theta. And it says, hey, sine is -3/5. Remember, sine is opposite over hypotenuse. That tells me, okay, I know that the opposite side is going to be -3. So here is -3, and the hypotenuse side is 5. We know the hypotenuse is going to always be positive because a hypotenuse can never be negative because it's a sum of two squares. With that said, if I was going to find the cosine, remember the cosine of theta is the adjacent side over the hypotenuse side. Well, here I don't actually have the adjacent side. I don't know it. So I'm going to need to use Pythagorean theorem. So I know -3 squared plus b squared equals 5 squared. So I get 9 plus b squared equals 25. Subtract 9 from both sides, and we get b squared equals 16. That gives me that b is just 4. So I know for sure that adjacent side is 4, and it's on the right side of the x-axis, so we call it +4. So the cosine is the adjacent, which is 4, over the hypotenuse side, which is 5. All right, so now this is kind of a review, but now we're learning 3 new trig functions that we've never seen before that you haven't learned in Algebra 2. So let's recall what we remember about sine. Remember, sine is opposite over hypotenuse. Well, its reciprocal function, cosecant, this is the abbreviation for cosecant, is just the reciprocal of sine. So if sine is opposite over hypotenuse, this is going to be the hypotenuse over the opposite. What's cool about that is the second that I know what sine is, I can just flip it, and I know I've got the cosecant immediately. Let's look at the next one. So cosine is adjacent over hypotenuse, and just like we said before, the reciprocal is secant, and it's the reciprocal of adjacent over hypotenuse, so it's going to be hypotenuse over adjacent. So as soon as I know cosine, I can immediately know its reciprocal function secant just by flipping it, and vice versa. And then the last one here, tangent is the opposite over the adjacent side. So cotangent, its reciprocal, is adjacent over the opposite, okay? So with that said, we also need to remember that sine and cosecant are reciprocals of each other. We also know that the cosecant is the reciprocal of sine, and we call the cosecant abbreviation, we say it's an abbreviation for cosecant. We know that secant is the reciprocal of cosine, and secant is an abbreviation for secant. And last one, cotangent is the reciprocal of tangent, and cotangent is the abbreviation for cotangent. Okay, when we're looking at this, this is really important to remember too that C goes with S and S goes with C, never together. So sine does not go with secant, sine goes with cosecant, cosine goes with secant. And then tan and cotangent are pretty easy to remember. All right, let's look at this one. So again, if I'm looking, here's my angle, that's where I'm pulling from. Here's my opposite side, hypotenuse side, and adjacent side. So for the sine here, I know sine is opposite over hypotenuse. That's going to be 5 over 13. Well, immediately I know the cosecant, which is 13 over 5. That's reciprocal. For cosine, it's adjacent over hypotenuse. So again, that's going to be 12 over 13. Find that's reciprocal for secant is 13 over 12. And then tangent, I know, is opposite over adjacent, which is 5 over 12. So its reciprocal is cotangent, and it's 12 over 5. All right, this next one here, remember, anytime they give you this, this is a clue. They're saying, hey, between pi over 2 and pi, so remember on our radians circle, we know here's pi over 2 and here's pi. So if they're saying, hey, this is between those two, we're talking about that second quadrant. And that sine of that angle, so let's draw the angle here. Here's sine, is 8 over 17. So sine is opposite over hypotenuse. So this is opposite side is 8, and the hypotenuse side is 17 from here. Okay? If that's true, they want you to find all 6 trig functions. Your 6 trig functions, again, are sine, cosine, and tangent. Okay, and then your other 3 are those reciprocals. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So if I know the sine, which is opposite over hypotenuse, I do. They already gave it to me here as 8/17. So we're going to find the reciprocal, which is just 17 over 8 for cosecant. Now, to find the next one, I do need to find the adjacent side. We don't have it here, so again, we're going to use our Pythagorean theorem. So I know a squared plus b squared has to be 17 squared. This, we're going to subtract 64 from both sides. And we end up with b equals the square root of 225. Okay, so if this is 15 and it also goes to the left of the x-axis, we know it's going to be negative 15. So don't forget, sometimes it ends up being negative based on what quadrant it's in. So my cosine is a over h. That's negative 15 over the hypotenuse. That tells me the secant is just the reciprocal of that. Super easy. Lastly, tangent is opposite over adjacent. So opposite side is 8, adjacent side is negative 15. Take its reciprocal, and we get negative 15 over 8. Okay, last thing that we're going to learn, what's positive and what's negative in these quadrants. So here's what I want you to remember. All students take calculus. This tells you what trig function is positive in each quadrant. So A stands for all. Everything is positive in that first quadrant. Here in the second quadrant, only sine. Here in the third quadrant, it's only tangent. And here in the fourth quadrant, it's cosine. Okay, so it's sine and its reciprocal function cosecant, tangent and its reciprocal cotangent, cosine and its reciprocal secant. So what quadrants where can theta be if sine is greater than 0, that's positive, and cosine is less than 0, that's negative. So where is sine positive? Well, I know sine is positive here, and sine is positive here. But where is cosine negative? Well, I know cosine is not negative here, but cosine is positive here. So we know that this has got to be in quadrant 2. All right, let's do the next one. Oops. All right, looking at the next one, it says, where is sine and tangent have the same sign? Well, we know everything is positive here, so that could work. Sine is positive here, but tangent's negative, so that's not going to work here. Tangent is positive here, but not sine, so it's not going to work here. And cosine is positive here, but sine is negative, and so is tangent. So it is positive here, or the same here as well. So in both quadrants 1 and quadrant 4, they both have the same sign. Okay, the last one. it says, where do cotangent and secant have opposite signs? Remember, cotangent and tangent are going to be the same positive or negative in the same location, and secant is the reciprocal of cosine. So that's really what we're talking about here. So we want to know, where do they have opposite signs, meaning if tangent's positive, cosine's negative, and vice versa. So where is tangent positive? Well, tangent is positive here and here, but we want to know, where is secant opposite of it. So secant or cosine is also positive here, so this is not going to work for us in the first quadrant. Here in the third quadrant, cosine would be negative, so these are going to be opposites here. So we know it's first for sure in quadrant 3. We can also see here tangent would be negative here, but cosine would be positive here. So we can say it's also in quadrant 4. All right, that's all we have for today. See you in class.